Tuatara, the Māori translation is many peaks. So it's just talking about the back and the spine down the back. Tuatara are locally extinct. So on the North, South Island, they're extinct. They're all taken out by the rats and stuff. So all the ones you see have actually come from the islands around the place, which are the ones that are basically far enough away from the coast that rats couldn't get to them, and also the difficulty in terrain, which is the likes of this place. This is Takapōrewa, or Stevens Island, and it's in the Marlborough Sounds. Top of the South Island, they've got all those little islands dotted around. Right on the far western corner, there's one called Devil Island, and then right beside it is Stevens Island. And they estimate there's about 45,000 tuatara on this island. So it's about 130 hectares, I think, which is about twice the size of the southern enclosure, so it's not very big at all. And one of the things you get on there is a lot of seabirds, like titi, muttonbird, and they have a burrow as well. And literally when the mum and dad are out looking for food, the chicks will pop their head out and there'll be a tuatara waiting there, and it'll just bite its head off. Head's got all the good stuff. Oils and things like that in the brain is always a very healthy thing to eat. Sounds gross, but the brain's actually really good. Big giant bears over in Canada, they hunt salmon, and they literally will just eat the roe, which is all the eggs, and the brain of the salmon. They won't bother with the rest of it. So it's kind of an unknown universal fact that brains are good. So this is where we got our tuatara from. We got 40 out of this. There's 20 in here and 20 on the maunga. And what happened is basically we use this picture here for little tiny kids, because most people associate a helicopter with the wealth or expense. So this is a couple $100,000 a day to get 220 tuatara off that island onto the mainland and then distribute them. It's actually quite a big deal here. There was a big massive kōpiri till about 11 o'clock at night here. It was real cool. I wasn't part of it, but I've heard many stories. This is just to really give Doc a bit of grief about their green colouring. This is a juvenile or a young female. And basically female's got less spines down the back. It's just not as big or dominant, where the males are quite a bit bigger and the spines are bigger. But can you see the hole in the background? This is what we do because translocating any species, bird, reptile, whatever, is really, really difficult. You know, it's quite stressful. Imagine you're just taking it out of your home one day and put it in a completely different country. It's the same sort of thing. So we provide a home, which is basically a square box with a lid, and then two tubes coming off with the entrance and the exit. What we've found is actually they pretty much just use one tube. They might go and turn around, but they always live in the one part. They don't bother with the whole three-tube sort of thing. And then we've also seen them make their own burrows as well, which is good. Now for the nitty-gritty. In the top left-hand corner you can see there's a male at the top and a female underneath. Top left, top right. Because you guys are old enough, this is procreation. Okay, these guys are having intercourse, or however you want to put it. Before they've even got to the stage, the female would have been trying to eat as much as possible. Reason for that, we think it takes up to about 18 months to accumulate all the nutrients she'll need to actually carry her young. So it's enough to make the yolk sac, it's the right nutrients to make the actual egg itself and things like that. Then she'll find herself a good looking fella, they'll breed, and then it's between a year and 3 years she'll carry those eggs before they'll hatch. So the reason for that, if it's a year, the belief is that the conditions are right, they have lots of food and things like that, so she has enough nutrients and constant nutrients in the right sort of temperature range for them to form quickly. If it's 3 years, it means that there's been just a lot less food available and the wrong conditions really for her to carry. She will then eventually bury them, kind of in a shallow sort of burial. It's a little bit like a, you ever seen an alligator nest on TV or a tortoise nest or something like that? They basically shallow bury. And you might see maybe just little caps sticking out at the most. And then quite a few weeks later, the tuatara will basically be active and pop. See the little tiny spike on the end? This is called an egg tooth. Some birds, some snakes and some reptiles have egg tooth. And basically it's like a single scale on the end which just will pierce the egg. It's not like a chicken egg which will crack. This is like a little leathery ball. So it's got to break that open to get out. And then you can see the yolk as well, which we believe the yolk will probably feed it for a couple of days.
How many offspring does she have?
My understanding is about 8 or 9. So imagine carrying 8 babies in 3 years. That'd be awesome. You got a little baby tuatara, which will actually probably would have been about 8 centimetres long. And what we believe or what we know is that tuatara juveniles are more daytime buzz. So even though tuatara are nocturnal, the reason they're in the day is because these guys are independent from birth. As soon as they hatch out, they're on their own, they've got to feed themselves. Mum and dad aren't going to come along and give them a meal, because if they do, they are the meal. Mum and dad will eat them. So tuataras, the way we explain it, is that they're opportunistic feeders, which means they'll pretty much eat anything in front of them. Now for the crazy stuff. So tuataras are a very ancient lineage of reptile. You ever seen like a family tree of species, and they'll give you a branch and say this is one species and another one on the next line? So in reptiles, you'll have a branch for snakes, you'll have a branch for reptiles, or certain lizards and skinks and stuff like that, and then alligators have their own branch as well. These guys have their own branch. These are 220 million years old in their genetics. So they're pre-dinosaur. Dinosaurs died out 67 million years ago, and were around for about 100 million years before that. So these guys are older than dinosaurs. They are not a dinosaur. Everybody calls them dinosaurs, but they're actually not. And some of the really weird adaptations they have is that this little blue dot is a third eye, which is handy for some, not for others. And it's only there for a little while. Basically, as their skin heals, or not heals, but as they grow older, it'll cover that eye up. And then they believe it's still there, it's just not in use. It's not a fully functioning eye. It does have a retina and a basic lens. But back in the day, the only thing it would have had to worry about was a big kahu flying over. So it will see the shadow or the movement above it and then run off and hide. Because the difference between an adult colouring and a juvenile colouring is quite drastic. As they get older, they can kind of somehow, we don't know, but change their skin colour as they shed every year sort of thing. So sometimes they'll get lighter if they're around the grass, if they're more in rocky areas, they actually go greyer in colour and things like that. So as a juvenile, it'll see something fly and it'll run away. As an adult, it just stays still and won't move at all. But that's when the mammals kind of buggered things up, is because rats or all mammals use their nose. They can smell stuff. And these guys smell funky. All the birds that live on the ground smell real funky. So that's basically what led to them being locally extinct, is that their natural defence didn't work. Tuataras have a really, really slow metabolism. So when I was talking about those eggs and carrying those eggs for so long, that's the reason why, or one of the reasons, is that their blood flow, their heart rate is real slow. They breathe every 10 to 15 minutes. So literally just see them go, and that's it. We used to think that they lived to about 120 years old. I personally believe it's probably around 200 years old. And that's what a lot of the theories are leaning towards. It's just none of us have lived long enough to see it. And that's basically real slow heart rate, real slow metabolism, slow breathing. So if you want to live forever, hardly move. That's the thing, everybody thinks these guys are really slow, but actually they have really, really fast reactions. I've seen one catch a fly, I've seen one catch a fantail, which really freaked out the grandmother on the day. She had her kids with her, and it's like, hey, look at this. I was like, basically begging like a little schoolgirl. Oh my gosh, this is brilliant. She was just like mortified. It's just like it's nature. Basically